Good morning, everybody. I'm so happy to see so many brilliant faces in this room. So thank you all for coming. Let me just start out by saying the most important thing. The Wi-Fi access will be working in a few minutes. Okay. My name is Ole Sejers and I am professor in child computer interaction here at Aarhus University. And this is Rachel Smith. She's assistant professor, also here in Aarhus, and she's been chairing this FabLearn Europe conference. So on behalf of Aarhus University and our partners from Bremen University, Stanford University, Silkeborg, Vejle, and Aarhus Municipality and Spinderihallerne, we want to welcome you all to this first FabLearn Europe conference. We're very fortunate to have more than 240 people that wants to share our concern for fabrication technology in education. Honestly, when we started the mission of making a FabLearn conference, we were thinking about having sort of a pre-IDC conference event, and I remember that Rachel and I, we were booking a room for about 30, 40 people. And look where we are now. The vision for the conference is to bring together international researchers and practitioners to share concerns and perhaps even create thoughts for action in this highly interdisciplinary community. So guys, I hope that all of you are ready to work, to share your knowledge and your concerns and have your fingers and hands out of your pockets, because today we're not just going to talk about new technology, we're also going to use it. Rachel?
Thank you. Yes, so we have a packed program in front of us today, and just to give you a little bit of help, because we need your help in terms of the logistics. This is a very sort of difficult program to set up and to make work. So as you may have noticed, all breaks are cut out of the program, so you don't actually know if you have a break or when it is. But that's on purpose, because we don't want you hanging around out here. We want you to move while you're having your break. So after the first paper presentation session, which will go on to 11:15, something like this, then you'll have 10 minutes to get to your first workshop destination. So I hope everybody now knows where their first workshop is, not by having been there, but by having checked the program and at the registration desk that you are actually on the workshop that you thought you were. We are in 3 locations. Some of the workshops are in Nygård. They're just over here, very easy to find. Then we have some in Digital Design Lab, which is also in that direction. So you need to move out of this door up here or here. And then we have in Cuba Science Park, which is across the street, and you have to walk for 100 meters or something. So some of you may know where it is, some of you may never have been here before. So follow the crowd and the people who are screaming in Cuba Science Park, and we'll get you there. For lunch and demos, we are back in this room out here. And then we have a second round of presentations in this auditorium before we have a second round of workshops at those 3 destinations again. And then finally we end up with demos and drinks and tapas out here as well. So you'll be moving about all day, and because we're spread out in so many different locations and activities, we hope that you'll help us collect some of the experiences and discussion points using this hashtag on Twitter and Instagram, so that we actually can see what each other have been doing during the day. There's so many exciting things going on, and we really want to thank everybody who's contributed to making this day possible. All the workshop holders, the demo presentators, and the paper presenters, keynotes, everybody who's helped with the organization, especially Spinderihallerne. So welcome everybody, and I hope we'll have a great day together.
So we'll start this morning program with some very interesting paper talks, and to chair this session I have the privilege of introducing Janet Reed. She's professor at the University of Central Lancashire in the UK, and she'll be chairing these first paper sessions. So, Janet?
Right, we need all the paper presenters to be really, really fast and ready. So, who's the first? Do we have the first? Nadine? Right, you run. Get there. Okay, so the second person on the list has to be ready to be headsetted as soon as, well, kind of during the first, is that right? During the first one, is that what you want to do? Yeah. Okay, so the second person has to be down here ready to be headsetted. And then as soon as this one starts, the next one has to be ready. Okay? Got the idea? Now we have to go really, really, really fast as soon as we've got you going. Okay. Okay, I'm not going to spend ages introducing people. This tends to be on the first slide. All right, so there's no need for me to say what people are going to say on the first slide. When you start, guys, can you all just get straight into it? Hold your slide at the beginning. Don't tell us your life history. Just get in and tell us about what you want to know. Go for it.
Okay. Hello, everyone. Good morning. I'm Nadine, and I'm going to talk about programming jewelry. That's a workshop, and our intention was to reveal the models behind digital fabrication. That is work that I did with my colleague Eva, who's sitting there, and my colleague Sabrina, who's back home in Bremen. So our starting point is that in Fab Labs, digital models can be transformed into graspable objects, which is a great thing to do. But normally, drawing software hides basic principles. You know, as if you want to have a rectangle, you click once here, and you click once here, and then you have your rectangle. On the other hand, if you program a rectangle, you have to define a vertex and a width and a height, and then you get your rectangle. If you want to have a second rectangle next to it, then you have to think about where's my first one? Do I want it to be the same size? How do I want it to be placed compared to the first one? Stuff like that, that you normally don't do so much when you use common drawing software. So our idea was to provide deeper insight into underlying models by programming. And what we did, we had a workshop with a laser cutter. We had 11 girls from 13 and 14 years old. We had 3 tutors, 3 hours of time, and we made the girls program their own jewelry using the processing programming language. What the girls did, this is an example of what they did. So they first made a sketch. Here you see the heart. Then they translated it into processing code. They created a PDF of it, and then at the end you see what they made for their jewelry. And what we found out was that all the girls succeeded in digitizing their ideas through programming, which is pretty good. They had full control and confidence in mastering the programming commands, which is we only gave them a blank program of processing and 3 code lines to do that you can see here, which is arc, so they made circles, line to make lines, and a rectangle, which was not used in that case. So the girls all the time knew what they were doing. And that's how we think this could work. So we gave an example on how to unveil digital models in working with digital fabrication machines. And also we found an idea how to combine design crafting of personally meaningful objects with computer science concepts. So now you made me hurry. We have a demo that you can take a look on, and thanks for listening.
To warm up the audience, we're allowed 2 questions because you were so fast.
Yeah.
So have we got a couple of questions? Anyone got any questions for this? Come on, opening presentation. This is your big chance. Oh, dear me. Anybody? Ah.
The programming the girls used, you did it?
No, that was processing.
Yes.
Yeah.
What's the, it's Java, or?
Sorry?
What did they use to write the code?
That's a processing environment.
Yes.
And we had a blank screen first,
okay,
so
yes.
we explained everything. The only thing that stayed a black box is how to create a PDF. So you have the begin record for PDF,
Yes.
things like that. But the rest, we explained them how to change the size of the window, and background color. That's what we taught them to do, and then the rest they did it all on their own. We had handouts with how to create a circle and how to create a line and a rectangle. So they made it all on their own, and we helped them. Thank you.
Do we have another quick question? One up here. I've got a runner. You do need to use the mic if you're asking questions, because this is being streamed around the world, okay?
Well, my question is, was there any of the girls who showed that they didn't want to program, saying that I don't like computers, I don't know how to do it, so they were they didn't want to participate in, they were backing from this project, or were they all enthusiastic?
They were more enthusiastic because they all came, how do you say, voluntarily. So they were willing to learn about programming. And no, they didn't have any prior experiences, so we thought, oh, let's see how it works, but it worked pretty well.
Okay, we will say thank you for that one quickly, and I will change over.
Thank you.
Seamless. Microphone.
Hi, everyone. I'm Susana Tesconi. I'm collaborating with Laboral Centro de Arte en Creación Industrial in Spain, and I'm presenting an experience, a paper I wrote with my collaborators, Lucy Arias, that is seated there. And the presentation is about an ongoing program promoted by Laboral in collaboration with the Ministry of Education of Asturias in Spain. The program promotes the creative use of technology in order to produce methodological change in teaching practice. Digital Fabrication and Making Line collaborated with 9 public schools. Out of the 23 schools, we collaborated with the other lines. Laboral is a multidisciplinary institution that promotes access to new cultural forms arising from a creative use of ICTs. From an educational point of view, it works like an expanded classroom in collaboration with local education institutions. We use the Fab Lab of the Art Center like an education laboratory where learning happens by sharing and by making. The practice of prototyping is extended from objects to activities, allowing teachers design learning environment where decision making and problem solving are like strategies to work on basic competencies. In the paper I present a case study that is one of the 9 schools we work with. It is the case of a public school, La Pereda, a public primary school that is in a small unitary rural school where that combines students of different ages in the same space. How we worked. We start with a teacher training. The teacher training was planned as a group investigation process aimed to produce and evaluate educational activities which uses digital fabrication as resource. After introducing the teachers to the digital fabrication and making, we invited them to write a year-long project and using the resources of the Fab Lab. They decided not to define a particular object to design with the kids, but they decided to let the children free to explore the Fab Lab and to choose how to use it. After that, and several meetings, the group decided to build a new house for the silkworm they were growing at school. The decision was made on the basis of a real fact, the death of several the death of several worms because the bad design of a previous box. Teachers and researchers were facilitating the process. Also, that is very important, is they decided to choose the topics from the official curriculum to treat in class depending on the needs of the research the kids were running. So, for example, they decided to work on angles when the group was discussing the design for the modules hosting the silk cocoon, where the angle is a very important feature. The co-design process ended with the production of 2 boxes and 2 types of supports for silk. Currently, the kids are testing the prototypes and adjusting the design. In the design of the learning environment, we followed the logic of explore before design in order to improve creativity and enable children to be familiar with the potential of the Fab Lab. And I'd like to show you a contribution, a very short contribution from the teacher who worked, no, it doesn't work, sorry. No. So I'm gonna conclude with that. I have time? It's 20-second videos. Okay. So the findings of our small research is in the design of the learning environment, we follow the logic of explore before design in order to improve creativity and enable children to be familiar with potential of Fab Lab. This approach allows you focusing on learning process and enable children to manage how to acquire the knowledge they need. So to let the children explore resources and decide how to use them offers a big opportunity for teachers to observe learning process in action. This kind of observation makes it easier to use the curriculum in a more flexible way and to establish a better connection between curricular content and the interest of the learner. So this is what we found. Thank you very much.
Do you have any questions for this fine piece of work from... one at the back there. Run! If there's people wanting to see things like these videos, do try and catch people over lunch, because we can probably facilitate some more conversation over lunch. So don't be shy.
Hi, I had a question about, in your paper you talk about getting students to be committed to long-term projects. Could you elaborate a little bit on that? Because I thought it was a very nice point in your paper, the 5 or 6 guidelines that you put forward at the end.
You mean the old program?
Getting the students kind of committed to a long-term project.
Yeah, this is a very good way to work for us. And actually, when we made an evaluation together with the kids, they asked for more hours of making certificate to have the possibility to access the lab more times.
Yeah, but I think you see in many projects outside that students always ask for more time, but I think in your paper you tied it very closely to the educational outcomes. Can you explain a little bit more how you did that?
You mean the art center? Sorry, I think I don't...
In the 2 cases you presented, they're very tied to kind of, the traditional curriculum in the school.
Yeah.
Compared to, let's say, other Fab Lab kind of things which are extracurricular. But maybe we can take this up during lunch if you'd like. Because I think you have some guidelines at the end of your paper that I think are very nice, and I was hoping that you'd share some more with the audience. I guess it was kind of more of a comment than a question.
Okay, thank you.
Okay.
Moving on.
Oh,
Yep, you ready?
sorry. Yeah. Okay, hello everyone. My name is Nancy Otero, and I'm collaborator at the TLTL Lab, and I'm a co-founder of Ingenio Digital, Fab Lab Mexico, and I'm here to present an ongoing program in Mexico City that is called Makers in Residence. So I'm going to show a small video, well, not as small, it's a little bit noisy, the video. I apologize for that, but Okay, so this was our project, and this is a customization of a program that the TLTL lab developed already that is called Makers in Residence. So in the program that the Stanford developed, students, instead of going to school, they go to the Fab Lab at school at Stanford during 4 weeks. So they spend 24 hours per week doing this during 4 weeks. When we try to implement it in Mexico, we look for a high school that will allow the kids go to our Fab Lab instead of going to school. That didn't happen. So we have to run it as after-school program. And what we did is that we partnered with a university that had already the machines there, and we run 4 hours every day for 4 weeks. So kids will go to our program. We also train the facilitators in this school to help us run the program. And this is a very interesting implementation because the students were randomly selected, meaning that there were not the students that wanted to participate in the program, either the students that were like the best students at the high school. So we invited 70 kids total, and for them 36 wanted to participate. We have a very high completion rate, even if it was a very difficult circumstance, because sometimes our program will go conflict with activities at school. Also, we were not giving any extrinsic reward. So the school was not giving better grades for the kids for participating, either like any points. We were not paying the kids neither. And the university was 1 hour away from their high school, so they have to go in transportation for 2 hours every day. So what was some of the analysis that we are coming out? So even if it's very difficult for kids to participate in these programs, if there is like a very engaging part, they will be able to do it. This is also a very good way to promote collaboration between institutions. So the university where we partner, they're also at the end of the first program, they were so excited about some of the projects that the kids did that they offered some scholarships for them to go to the university. But on the other side, this is just a one-time experience with no continuation. So because there is no Fab Lab in their high school, they cannot continue developing their own projects. They cannot continue linking what they learn with digital fabrication, and sometimes, of course, it has conflicts with activities. We did some quantitative research. We've drawn some surveys before and after the program, and we have a very big control group. But we were also interested in qualitative analysis, not just quantitative. And this is some of the very, very preliminary analysis. We have a lot of technological awareness, like now I understand how things work, now I know how remote control works, how a car works, a lot of self-efficacy, and now I'm able to do things that I never thought I would be able to do, and some other interesting comments, like now I realize that we are smarter than machines, or they can see that people with few resources like us can do great things. So we are still going to run 3 more of these programs this year in Mexico, and we are also like trying to look for different ways to implement this in a sustainable way. We found that partnering with a university and having undergrads as a facilitators is a good way to do it, but we are like open for suggestions to make this more sustainable. Thank you.
Thank you. Right, any questions here? Or any questions? Are we? Oh, no. Right, well, I'll ask the question. So you said that, I was a bit confused because you said in Mexico, but then you said at Stanford.
Oh, so this was a program that it was developed at Stanford, and we wanted to customize it and make it possible in Mexico. So the first program where kids go to school, where they went to the Fab Lab instead of going to school, is at Stanford University. And when we make it possible in Mexico, we have to do it as a after-school program.
Someone else say something? Yes. Any more questions quickly? No? Didn't warm you up? While you set it up, take that one. Yeah, while you set
I just wanted to ask which university you were working with in Mexico, and was it a specific department or program at that university?
So yeah, Tecnológico de Monterrey was the name of the university. And what was the second part of your question? Oh, it was, we were working with the mechatronics department of the university.
Okay, thank you. Right, I've been told I'm supposed to introduce people. So this is Mikel, and from Aarhus doing work with Ole, who's on the front here.
Thank you. All right, so let's talk about digital fabrication. What's wrong with this picture? Well, we put computers in the classrooms to save education, and I suppose we got smarter. So we got interactive. This is an interactive whiteboard. It interacts with the teachers. So perhaps paper would call for more interaction. All right, so the next classroom technology is digital fabrication. But we need to ask ourselves, of course, how we want to do it. We also need to ask ourselves what digital fabrication is, but most of all we need to ask ourselves, why do we want to spend the limited time of students with digital fabrication? Well, first of all, what is digital fabrication? Is it a design process? Perhaps. There are examples about collaborative learning through cycles of failure and redesign. That sounds to me like a reflective conversation with the material. It could also be about being designerly. And if we are to teach, or if this is a design process, then we need to not just teach certain skills, it's about an educational formation, which I'll come back to. But in order to answer the question of why we should spend time on this, I think we should go to the ancient German concept of Bildung. Kant framed it as man's release from his self-incurred tutelage, and through understanding, through knowledge. It's from the age of the Enlightenment. As you can see, it's old. It's Klafke framed it in terms of emancipation, empowerment, and citizenship. So these actually give us a direction for learning. These we can use these to choose between different good skills, different literacies, different competencies. So what is Bildung for the 21st century? Well, we've chosen to call it Design Bildung, this new concept, and it has something to do with being designerly with technology, because that makes for better citizens. It helps emancipate, it helps empower in the society in which we live today. And when it does this, this is not just something for designers, this is not just for engineers, it's not for the chosen few in Silicon Valley, this is actually for all. This is what you in German would call Allgemeinbildung. So what is it? Well, I'm trying to find out. But has something to do with the ability and motivation to act and think designally. And it has something to do with the concept of technological imagination, which is being able to imagine or envision preferred states of the technology. All right, I don't want us all to be Neo, but we still need to have some kind of perspective on what it is technology does to our everyday life. And I have something jammed here. Here. All right. In order to accomplish this, we need to again not just be taught a certain skill. We actually need to go into, we can say, a transformation. We need to talk about transformational learning. All right. So what are the implications of taking this design building perspective? Well, we need to focus on solving real-world problems that are authentic to the students, and we need to do it in ways of complex problem solving, because that's how the real world is. We need to see technology as a design material which can be formed, which can be transformed into preferred states. And we need to look and incorporate the entire design process into digital fabrication. That was it. Thank you.
Thank you. So, time for some questions here. Come on, somebody must be wanting to know more about Design Bildung. No? We've got one there, Tilda. Right.
Yes, very interesting analysis. So, do you have an idea how that could be translated in a concrete activity in a classroom, or is that too early to ask?
Well, to be honest, I have ideas, but it is a bit early. But as I stated, it's about incorporating the design process. So it's about finding real-world problems, trying to solve them with design processes. I think that's about as concrete as I can get.
Well, maybe over lunch I can ask you for detail.
Sure.
Okay, thanks.
Yeah. Okay, thank you. Thank you very much. Next one on, yeah. You want to take another question? No, we've had it. Go. Right. Thank you. So now we have Now we have Emilia from the Netherlands, but she's really Italian, okay? But yes, you're working in the Netherlands.
I studied at TU Delft in the Netherlands, yes,
Right.
but I'm from Italy.
Right, introduce yourselves, Emilia. Go on.
Yeah. Good morning, everyone, and it's great to see you all here. I'm Emilia Pucci, and this is not a class on astronomy, although there's a lot of stars going on. It's all about Fab Labs, and the concept of the star is related with the fact that during my graduation project at TU Delft, I found out that there are a lot of hidden stars in the world, and that my passion is to find a way to empower them with the tools to shine up their own light. The hidden stars that I had the chance to meet during my projects are young adults of an underprivileged neighborhood in Rotterdam. They have a problem that they are perceived as a problem by their own society because they have a low level of education, low income, maybe a small crime history, but actually they are a potential resource for their own society, city, and for the world because they are digital natives and they are born with technology that many of us are still trying to figure out how it works. So that makes them tech savvy, very active on social media, and most of them actually quite smart. So my question was here is, how can we trigger their skill development? So I organized, in collaboration with the coach of a school of this neighborhood, Afrikaanderwijk, a workshop on 3D printing, in which, through the steps, the idea was to unlock the confidence of the students who shared their passions, shared their ideas, shared their designs, learning how to 3D print at Fab Lab in just one day. Then they shared their knowledge by making an Instructable, their opinion, giving me feedback how the workshop had gone, and then they went back to their neighborhood and shared their experience with their peers, which was not easy because their peers were, for them they were weird. So since actually the students got a very good impression of this thing and they managed very well, how could I build an empowered community that could be self-sustaining on the long run? So the idea came to get a peer-to-peer workshop platform combining physical touchpoints, Fab Lab and a school, digital touchpoints, Facebook group, Instructable website, and two ubiquitous technology elements, which I will not go in detail, but we can talk about it at the demo or later at lunch. So this is the constellation, so the way that the students will be able to shine through the various steps of the platform, and I'll walk you through the steps. The platform launch will be an event in which the coach or the teacher is going to invite the students to a Facebook group, Ik Ben Sterk, and tell them this is going to be our communication means for the whole semester or time that the thing is going to go on. Then the students design their own badge, which will be their access and membership to the group. In a continuous cycle, so this will be something that goes on, the professor launches a call for teams, and students basically compete for which is the best theme for the workshop, and the winner becomes the chief in charge. So one of the students gets to organize the workshop, invites his peers, and during the workshop day facilitates his peers to design and make an object, make an Instructable of it, and rate the workshop with an interactive prototype that you can also see at the demo later. Last thing is, during the Be Inspired Day, the students go back to their school and inspire the other students that are not part of the platform to join in and at least to see what's going on. So here the concept is very nice, but how did I test this? Well, thank you. I created a Facebook page, Ik Ben Sterk. I invited the students from this school, just a small group because I was having access to a small group, and invited them to this workshop on laser cutting. The students came, designed their idea, worked on Illustrator to make it into a vector format, and learned how to laser cut it in just a few hours in one day. At the end, they evaluated the workshop with a prototype of a token trophy that I made for them, and honestly, they had even less trouble than with the 3D printing. They learned laser cutting in no time, and I was very surprised, but since I had to confirm the results, and after all, it's a Master of Science, you have to prove that this is not just a lucky go. So to confirm this, I organized another workshop on laser cutting, invited more students to it, and went through the same process. The incredible results of this second workshop on laser cutting is that not only the students from the school in Afrikanenweg joined, but another school learned about the workshop and asked to join as well. So I had students from 2 schools who in one day, without any previous exposure to any technology or to Fab Labs, learn how to go from their own design to a finalized tangible object in just one day. And they didn't want to leave. So these students who are originally kind of dropouts of society and of the educational systems were insisting to stay, were creative enough to come up with something and make it. And I have to be honest, I think it took them less than to me to actually learn the technology. So the contribution for Fab Lab is, this is a lot of text, so I'll make it short for you. By embracing a participatory bottom-up approach to learning by making, students become not only co-learners, but also co-creators of knowledge, which empowers them to want to share their knowledge with the others and teach each other what to be. So the teacher is not top-down anymore, but is learning together, which is amazing. And by putting Fab Lab as a node of a network that is both online and offline, we can kind of relieve schools that don't have economic affordance from the necessity of implementing an internal Fab Lab, because you are using a Fab Lab in a network of a neighborhood, which could also implement a community that is not only within the school, but that can also tap from the resources of the neighborhood, such as local makers, other people that are involved in it. And yes, I think this is it.
Yes, so to the best of our knowledge, the next speaker isn't here. Can I just check in the audience that the Dundee are not in residence? Okay, so quick question. Yep. Oh, sorry. You can't get the stuff.
Hi, congratulations on the project. It's really good. And I wanted to ask you, I wanted to talk to you afterwards, maybe at lunchtime, but just a quick question. How did you get the teachers of the school involved in the project? Thanks.
Yes, well, it wasn't that easy because I went to a few schools in this neighborhood in Rotterdam, and one educator actually looked at me and he told me, "You really want my students to do this? Because they're low-level education, they're never gonna make it." And I was just flabbergasted, like, what are you talking about? So then I found another coach, actually by insisting, by talking. It's very bottom-up. It was very viral. I stayed in the street of this neighborhood for a long time until they told me, there's this coach who is cool and she believes in her students. And that's how I made the link. But still the issue of resistance from schools is very strong, so I would love to talk about that because it's been quite a challenge. Yes.
Okay, thank you. Thank you very much. Gosh, I kill myself. Right, so the last speaker in this session, as long as Dundee aren't here. Nobody from Dundee here? That's fine. We're going to close it with Nicholas from Roskilde University in Denmark. I have no idea where Roskilde is. Where is Roskilde?
Roskilde is in Denmark.
I know that.
On Sjælland, just south of Copenhagen.
Yes.
I brought a friend with me.
Right, thank you. Okay.
Right, I'd like to talk to you about empowering academia through modern fabrication processes. I am Nicholas Padfield. The co-authors are Michael Heldrup and Mads Hyby. Now it's supposed to advance every 20 seconds, but it is. Good. We are from FabLab Brook. FabLab Brook is not a machine, a room full of machines. It is, in our opinion, an experimental research and learning environment. And it's married with HUMTech. HUMTech is an education, a bachelor education between humanities and technology that started only 5 years ago. And we're in this sort of field. We're somewhere between people, design, and technology. And we know that this is important because people are still not very good at designing technology which people are good at using. It's just not very user-friendly yet. And we're very excited to see when it becomes user-friendly. Probably PCs will be user-friendly after PCs are dead. We have two cases. We built this little experimental robot to enable exploration of the human-robot machine interaction. It's sweet. Its little head has only one sensor, one distance infrared sensor, which you can turn around. It can look up and down. Because of the movement of the head, it can seem a little bit human. And we call this mass-produced custom technology because we've done it on a laser cutter, so we can make lots of them. We can make this standard. And we make it a product. We make it appealing, very easy to get going with, very, very easy to click together, but also hackable because the materials, medium density fiberboard, it's about $1. So we don't care if people break them up, cut them up, glue them together in new ways. Now, all this is, of course, only possible because of the open hardware movement. You can see we've made this manual, makes it easy to get going with. It's rather like an IKEA manual. So you click it together here, apply glue here. The software is modular. It is real code. It's real code that they will be able to use in their career, their life. But it's packaged in functions. So there's little functions saying, oh, follow people. Oh, run away from people. Here you see them. They're having their first experience with the live robot. It's powered up. And they can explore how does the internal complexity, how does the anima of this robot affect how people see it, how people interact with it. So the software is modifiable. The hardware is also modifiable. Because it's cheap materials, we don't mind if they muck it up every time. They are welcome to glue gun it, to add soft elements if that's what they want. They can make it, nice and furry, inviting to stroke. Some example modifications are, there's one student who took the laser files and changed them and put lots of sensors on, an ultrasound sensor and 6 long-range infrared sensors. There's a pincer robot that follows after you and tries to, catch you and pinch you. And there's a soft, nice robot. And it's very important, the rich media of the interaction with this robot cannot be described in text, not even in video. If I just showed you a picture of this robot, it looks a bit evil. It's black. It looks like Darth Vader. But actually, it's very sweet. If you come to it, it pulls its head in. It's a bit like a tortoise or a porcupine. There are also extreme experiments. And it's important to understand this is all the same basic platform. But this is a bristlebot. It vibrates and it moves forward. And if you put your hand in front of the sensor, it puts its foot down. It can only turn left. It turns around foot like this. And this is, it's anthropomorphic. It has a little doll's head that looks at you. It's really scary. But the point is you can experiment with, how do people see technology when it becomes a bit anthropomorphic. The second case is experimenting with hacking social interaction. We're not talking about technology here. This is where the humanities come to the Fab Lab. And we see what happens when you put strange boxes in the middle of Copenhagen main station and people get a little message saying, please go up to a stranger and ask if they'll eat an ice cream with you. And what happens? Do people do as they're told? And it's the social action around the box that's the interesting thing. It's not the box itself. Now, this woman doesn't understand Danish, so she had a long conversation with this Dane. She helped, asked to help translate. It's important to understand that we're not engineers. This is rapid prototyping just with digital media. This is what's inside the box. We do have an Arduino that's programmed to talk to the printer, but it's all just stuck together with wires and glue guns. And if it falls apart, it doesn't matter because we have 4 more of them. The point is the social interaction around the box, not the box itself. Now, the takeaways we have are, Sharon talked about the reflective practitioner, but he was always talking about, nurses, architects, professionals. What about us academics? We are supposed to love theory and deal with the written word and not do practice. But what about using Fab Labs to reflect on our own praxis? Now, Boxton had this point about a short iteration cycle. Very important, sketch with bits of cardboard and stuff. Now, technology has come so far that we can do the short iteration cycle, but we are no longer limited to cardboard. We can use rapid digital sketching. And we like to test how people actually interact with things. Now, this is a pogo stick made by some students for kids because they were irritated. These older girls were irritated that when they'd been children, people cheated. Did you touch the stick when you danced under it or not? Now, this has a sensor in it, so it just turns red when you hit it. So there's no cheating possible. Sometimes a working prototype is necessary. This is a girl wearing video goggles. There's an accelerometer and a headband. And the camera 3 meters behind her turns the same way as a head does. And you just can't prototype this kind of thing with cardboard. Well, it would take a lot of mirrors to do it anyway. So sometimes you do need to do a working prototype. The third takeaway is that the knowledge production in a Fab Lab is beyond a written report, beyond even other textual media like videos. The object itself is the knowledge contribution. This raises the question, how are we going to disseminate these knowledge contributions now in the post-Word era? And we feel that Fab Labs have a very important role. The only way to really experience the behavior of this robot is to build one yourself. Now, fortunately, this is possible if you have a Fab Lab at each end, just like we have the internet with a computer at each end. You can take our laser cut files and make this robot in your own Fab Lab. And the other important point is that it's not about technology. This is about enabling other fields at the university to use rapid prototyping to enable their wider experiments, testing prototypes. Thank you.
Thank you. Do we have any questions for Nicholas? Very slick presentation, by the way. I loved that. Everything timed, so I didn't need to jump out at all. Oh, we have another one from Tilda. Anyone else offering? Go on then. Are you still wide up?
Well, I can talk on this microphone, I've been told. Thank you.
So it's very interesting, if I understand correctly, you provide a sort of toolkit for children to play around with. But of course, if I look at the first one with the robot, how do you decide sort of the parameters that are fixed and the parameters that are flexible to give them some freedom in their design space?
Well, the laser cut materials we give them, and we tell them that they're allowed to hack. So in that sense, it's only their own creativity and what's in the room and what can they glue gun together that limit them. On the software side, to let them get started quickly, we have a row of packaged functions in code. So there's one called follow people, one called run away from people, and they can combine these in the order and magnitude they want. Yeah. So we let them hack as much as possible within the physical constraints of the real world.
Okay, thanks. Thank you. So can we thank all the speakers in that first session? They did a really good job. They kept to time. Bear in mind, you can see them at lunchtime or in the breaks that don't exist. And now I shall hand the microphone over to Ole. Thank you to all the speakers.